Okay, so we are using the next one we are going to use for the simple fixed point iterations. I think this is one of the example to show you how to use the numbers to do as a calculator to do the programmings. So this is very easy. So first of all, this is given functions. This is your function x, function fx. But in this question, they asked you to find the roots. That means we need to solve this equation, and then they give you us about something like this is your initial value. This is your starting value you need to go for. So first of all, what I did here, I just make it the function equals to 0, and then I try to keep my x squared on the left, and then the rest like this one and this one I just move to the right hand side, and this is what I have here. So because of that, I will square root this both sides, so this is what I get here, but this is a plus minus. But in simple fixed point iteration, I need the gx. So because they have the lots of variety of the option to choose, so that's why I choose for this. So I just choose for the positive side, so that's why I choose the x is equals to square root 2x plus 3. This is as my gx, and this gx later we use for my algorithms functions to get the fixed point iteration over here. So before we start, I just make some checking whether this gx is valid or not, or whether the calculation will be converged or diverged. So this is a way. I just try to differentiate this gx function with respect to x, and this is what I have here. And once I have this, I try to substitute with the my x naught, meaning that my starting value is 4. So I just put it inside the function here, and this is what I have here. And obviously this is less than 1, and that's mean my gx here is valid to use for the calculation. And just to remind you, our calculation will stop when they reach to this stopping criteria is less than 0.0005. So that means once the value is less than that, then we just stop our calculation. Okay, for first of all, this is a given initial condition. Your x equals to 0 initial values. So that means this should be 4 out in here, this one. Because the I here is just denoted as this is your x0, x1, x2. Because the I is just stand for your the loop number, and this is the column you're doing for the calculation to get the stopping criteria, or where you're going to stop your calculation is based on this column values here. So it's very easy. So now I just make my I here is equals to 1 over here, and then next, so what I did here, because this is the next value, the x1 actually is using this algorithm. So that's mean when your I equals to 0, that is your x1 equals to gx0. This is a 0 later, x0. So that's mean my g function is here. This is my g functions. So that's why what I can did here is just to make it equal as code, and then putting the formula. This is the square root 2 times x. So this is my x plus 3. So plus 3, and close the bracket, and here we have, this is the value for the functions for the new x1. And how to get this one, because purposely this is the xi minus the xi minus 1. So I minus 1 meaning that it's the previous value, meaning that this current value minus the previous value, and then you take the absolute values. So this is somehow like the formula in the number. You minus this, and this is entered, and this is what the value you have. And how about we going for the next one, for this one? So basically, if you look at this function, this algorithm, basically your new x is taken from the previous x value. That means you want to get for this value, you have to use this x, and you putting back in the function gx, and you get the calculation. So this process will repeat until the end. You get the something like the solution. So for simplicity, because of this, we can simply just drag our solution like this, and you get a solution. See, the moment you have your iteration until loop number 8 here, so obviously your value for xi minus xi minus 1 is less than 0.01. So that means the first value here we get is less than 0.005. Then we just stop our calculation, meaning that the loop number 9 we no need. And this is the answer for the calculation using the simple fixed point iteration.